Hello, this is my presentation for the implementation class for Lean Six Sigma. This is Karen Wright for Forging Ahead. For the metrics for Define, I went ahead in the PowerPoint and I will show you that we used different things for minimizing waste during production for the blade and the handle, strategically analyzing the forging process, increasing production by 100% by making more knives monthly, improving the forging layout to eliminate non-value added time, establishing 5S homes for the tools and the equipment. For measurements and reasons, I will show in the PowerPoint also that we did a scavenger hunt, and in that scavenger hunt we had multiple people go ahead and look for tools prior to doing the 5S layout in the garage for making it easier for grabbing tools while trying to make a knife, having their locations. So prior to that, we did a scavenger hunt with these people to try and find the tools. With the histogram, you can see the mean in for the peak of the curve was at about 154, which the bell curve is okay. I can show you a picture of the bell curve. So the picture of the bell curve shows you it's at 154. Standard deviation is at 43.65. That shows you that the spread of the curve or distance from the mean, it's spread out, indicating the outside bins, they're not connected. The inside bins are connected. The people that went ahead and did the scavenger hunt didn't have any clue where these tools were. So when they walked into the garage and they did this scavenger hunt, it was like almost like an obstacle course. They had no idea where the tools were. And even if you did have an idea, you wouldn't have known. There was no reasoning for where the tools were in the garage. It was basically a mess. So that explains the scavenger hunt, the histogram, the mean, the standard deviation. On the next slide of the PowerPoint, it goes ahead and talks about the fishbone chart, the cutoff wheel wear, and then it's got 5 main groups listed: environment, equipment, man and power, material, manufacturer. And then it's got the 3 or 2 subgroups for each one listed. Excuse me, just getting over a cold. And if you look at that, you can see how it's going through the groups, and they're brainstorming those 2 or 3 subgroups that, why the wear is happening. It could be, all different reasons. It could be the poor ventilation from the environment. It could be the speed of an angle grinder. It could be the pressure of someone pushing on the angle grinder. It could be incorrect angle from the angle grinder. For material, it could be the wrong hardness of the actual cutoff wheel itself. It could be something to do with the manufacturer, whether it was the gluing or material variance, something different with the material, So it went ahead and, these 5 subgroups, or these 5 main groups, and then the different subgroups all talk about what possibly could be wrong. So that's that chart, that PowerPoint, which you'll see when I send that over to you. The next one, I know you've already seen as well, the ANOVA Excel sheet, little side show. I know you can't see much over the foam for the video. This goes over the mean, the standard deviation, the minimum, the maximum, the median, the p-value. It talks about the mean tells you, you can find the mean by adding up the 3 samples and then dividing by the number of samples so that you can get the actual mean of the samples themselves. Standard deviation is measuring how far apart the data is spread out from the mean. So you have your mean in the middle, and then your standard deviation goes to the left and to the right of that mean. Then your minimum is your smallest data point. Your maximum would be your largest data point. Median is your middle data point when you line them up all numerically. P-value, that's a measure of your probability that could be occurring by chance. The lower the p-value, the more likely it's rejected. If it is less than 0.05, the result is said to be statistically significant, and there is an effect. In this case, the p-value is 0.038924, reflecting there's a significant wear. Excuse me. So that p-value is reflecting a significant wear between the 2 cutoff wheels. And whether you take the cheap cutoff wheel and compare it to the mid-price, or you take the cheap and compare it to the expensive, you're going to get the same result. The mid-price and the expensive wheel are very similar. They're almost identical. I can't remember if they were the same name brand or not, but they match up almost identical on both charts that I used on the next PowerPoint. So going to that, so you'll see here on this next sheet, so there's the time series plot, and then there's an X bar chart, and you can just kind of see a little bit. I know you'll see a closer look when you actually get the PowerPoint, but the time series in the X bar chart exhibits that the expensive and the mid-price cutoff wheels are comparable with wear. They flatline on the charts together, per se, and the cheap cutoff wheel, it becomes progressively worse. The time series chart shows the incline from the cheap cutoff wheel from the wear demonstrated. That's kind of that PowerPoint. Next one is going to be my analyzation of my evidence. So for PowerPoint 3, that one's showing you the standard deviation, which is reflecting how far apart the data is spread out from the mean. It leaves a wider and flatter area on the histogram, showing you that, the mean is in the middle, and then the left of that area where the bell curve starts coming up towards that mean, and then where the mean is actually centered, and then where the bell curve starts, where it's going down, and then you can see the bell curve actually start coming up on that right side where that standard deviation is as well. The people's times were very inconsistent for the scavenger hunt from the knowledge of the garage's items' whereabouts. The next one I put on here is the PowerPoint for number 4. My perception of the cutoff wheel fishbone chart is that it has 5 main options to consider and then brainstorm through the possibilities. PowerPoint number 5 gave a brief but good explanation of the prominent words often used in Lean Six Sigma. These words were mean, standard deviation, minimum, maximum, median, and the p-value. PowerPoint 6 explains the wheel wear when 3 cuts are made for each cutoff wheel. The time series and X bar charts are key visual aids in defining the comparability. The next PowerPoint slide is controlling the improvements and the process. Forger is intensely aware of the exact measurements of steel and wood needed for the blade and the handle. This minimizes wasting raw materials. When the blade maker is creating his masterpiece, he follows the 8 strategic standard operating procedures. Production has increased by 50%, is still growing. We haven't hit that 100% mark yet. We're at about 50%. We were making about 2 blades a month, or up to about 3. Hoping to make about 4 We'll see how things go. The circular forge layout eliminates crossing paths, which is a really good adventure that we're on. So that's going well. You complete a step, you move to the right, and you go on to the next step. Hanging the tools on the pegboard and putting the equipment away after each use makes it more user-friendly and cleaner and safer for everyone. So that's all part of controlling the improvements in the process. And lastly, DMAICS. Define, measure, analyze, improve, control, and summary. So, define, SIPC, process map, measure, 5S, current status measure, analyze, PFEMA, statistical data, improve, PDCA, or an action plan, control, the standard operating procedures, anything that's ongoing where you can do a check and balance act, where you can keep checking things out. And then summary. How did things go? What went well? What can you improve on? What can you use in the future? And then the things about the DMAICS that I will take forward in my educational adventure or my lifelong journey will be improving the order flow at work from the time it is received to the time it is made and shipped. Contribute ideas to a smoother flowing layout at work instead of hauling so many parts to multiple departments. Create action plan for cross-training to reduce bottlenecking when people call in or have vacation. And lastly, the knowledge from these LSS classes helps me outside of work troubleshoot a home as well. For example, putting least used kitchen items on top shelves, separating basement items so I know what is where and 5S'ing them. I know this advice will stick with me and continue to be put to use. Next, we will go ahead and show you the video of forging a knife and putting to use the standard operation procedures. To begin my presentation for the Lean Six Sigma implementation class project, we'll start by showing a display of how we organized and improved the forging knives layout in the garage for lean manufacturing. Just a quick layout of how we hung some things up, cleaned up the bench, put a circular motion of just how we used everything just to make it quicker and easier for lean manufacturing. Next, we'll go into an introduction to my husband, which is the forger, Randy Wright.
Good morning.
And then we'll go into defining the components of constructing a knife.
For starters, over here we will have the tongs. These are very important for pulling your metal out of the forge when it's very hot. From here we have an we have a bench grinder. Here we have an angle grinder. We have a 2-pound hammer. We have 2 different kinds of steel right here that we will forge together. We have a chop saw for cutting your metal. Here we have a bench vise. We have a belt sander. Over here we have a drill press. Over here we have the forge. From there we'll go to the anvil, and then we have our press.
Afterwards, we will build the knife aligned with the manufacturing standard operating procedures, and then we will have PowerPoints we will be utilizing in the video as well to validate the measurements and the findings. The different charts will indicate data and their compiled results.